Okay, today I'm going to show you how to do a linear regression on your calculator. Matt buys t-shirts for a company that prints art on t-shirts and then resells them. When buying the t-shirts, the price Matt must pay is related to the size of the order. 5 of Matt's past orders are listed in the table below. Anytime you are asked to do a regression equation or come up with an equation based on a table of values, the first thing you're going to want to do is take out your TI-83 and enter those values into your calculator. So if you can follow the sequence of buttons, these questions should be pretty straightforward. First, you're going to press the button Stat. Then you're going to choose number 1, Edit. And you're going to enter your table of values into L1 and L2. So L1 represents our number of shirts, and L2 represents the cost per shirt. Be careful when you're entering this data into your calculator. You need to make sure that your rows match up. So 500 t-shirts should be in the same row as the cost, $3.25. 700 t-shirts should be in the same row as the cost, $1.95. Once you've entered all of your data into L1 and L2, now you need to plot this data. So it's a little bit different than the y equals button. You have to press second y equals, where it says stat plot, just above the y equals button. You need to go into your first plot and you need to turn it on. Once you've turned it on, you need to choose the type of graph that you want to make. Now we're going to just leave it in a scatter plot format. Then it says your X list is L1 and your Y list is L2, which is where you entered the data. You want to make a note of that in your notes. So X is your L1 and Y is your L2. That way you know what each variable represents. Once you've done that, you need to choose an appropriate window. Okay, X represents your number of shirts. Now it's impossible to have less than 0 shirts, so you could leave 0 as a minimum. And the maximum value you have in your chart is 740, so we might put in a maximum of, say, 1,000 shirts. That seems like an appropriate number. Then we have to look at our Y values. Our Y represents the cost per shirt. Now, it wouldn't make sense to have a cost under $1, under $0, so we can put 0 as our minimum. And for our maximum, I'm seeing numbers from $1.69 to $5.20, so $10 seems like an appropriate maximum cost for the t-shirts. Now what you're going to do is you're going to press graph, and as you can see, the points that you just plotted show a nice straight line. So you're going to recognize that the points are forming a straight line, and you're going to choose to do a linear regression. Okay, note the word line in the word linear. So what you need to do now, in order to find the equation, is you need to go into that stat function again, but this time you're going to scroll to the right into the calc column, and you're going to choose linear regression, AX plus B, number 4. Now your L1 and L2 are your X and Y, so that data is already in there for you. You can skip the frequency list, and then it says store regression equation. Once they've calculated the equation in the calculator, we want them to store it for us so that we don't have to copy it down. So what you're going to do is you're going to press vars for variables. You're going to scroll to the right to yvars. You're going to choose number 1, function, and y1. So what this is going to do is it's going to take your equation and it's going to store it into y1 after it's finished calculating. So you're going to go to calculate, and it tells you that the linear regression is y equals ax plus b. So where a is negative 0.0065 and b is 6.5. So that would be your answer for A. We want the equation. So y is equal to negative 0.0065 x plus 6.5. So there we go. We just came up with an equation. Now B is asking you what the slope and the y-intercept of the equation of the linear regression function represent in this context. Now remember that X represented the number of shirts and Y represented the cost per shirt. So now it's asking about slope and y-intercept. Well, y-intercept always occurs at x equals 0. So if x equals 0, that means no shirts were sold. Okay, so before he's purchased any shirts, what's kind of the starting price of the shirts? So the starting price of the shirts is $6.50. Okay, then our negative 0.0065x represents our slope. Okay, and remember that for each change in x, our cost is going down by 0.0065. Okay, so for each shirt ordered, so as x is increasing, the price decreases by $0.0065. And I'm running out of space here. Now it says to use the linear regression function to extrapolate the size of the order necessary to achieve the price of $1.50 per shirt. Now we can use our calculator to do this extrapolation. We want to figure out where along that line $1.50 per shirt is found. So what you want to do is you want to go into your calculator, you want to go into your y equals, and you'll see that that equation got stored in y1 just like we wanted. And you're going to put in a y2 of 1.5. Remember that $1.50 represents the cost per shirt, which was our y value. And when we graph it, it will show us where $1.50 per shirt is found in our graph. And then we want to figure out, okay, where is the y equal to $1.50 along our line, which occurs at the intersection of the two lines. So you're going to press second calc, go number 5, intersection. You want to scroll close to the intersection and press enter 3 times. And it will give you an intersection of y is equal to $1.50 when x is 769 shirts. Now 769 shirts will be not quite there, so we're going to have to order that extra shirt, 770 shirts, in order to get the price to $1.50. So your y2 is $1.50 when 770 shirts are ordered.